So in today's lesson, we're going to learn about the general solution, which we saw a little bit in the example that we did on Friday, where we solved for tan and it was theta belongs to all real numbers. So that means there's going to be an infinite amount of solutions. So the idea that we're going to do when we get these general solution questions, or we have to solve over the entire domain of theta, first of all, you'll solve like you normally do between 0 and 2 pi. And then after that, you're going to use the idea of coterminal angles and saying you can make an angle coterminal by adding 2 pi as many times as you like. So we put the value of k in there. And probably when we were doing coterminal angles, we did 2 pi times k. And format-wise, generally that pi always comes last. I'm not sure why. But this is still 2 pi times k, even though the k is in the middle. And that 2k pi, that just means, well, if one of the answers was pi over 6 and I add 2 pi once, I'd be at a place coterminal with that. If I add 2 pi twice, I'd still be at a place coterminal with that. So it's basically combining the ideas of coterminal angles and solving like normal between 0 and 2 pi. So your first example that you have right under that, you can actually put an X through that because we're not going to do that example. We're going to do 2 other examples instead. So the example that we're going to solve for is 7 sine theta plus 1 equals 0. This isn't in the book, but you can cross out question 1 on page 574. Yeah, you can cross that one out, and underneath it put this example instead, and then put your work for this example at the bottom of page 574 as well. Interesting to note on this question. I don't think you'll ever get sine theta equals 1/7 ever on an exam. And if it does get put on an exam, when they make the answer key, they'll decide we're going to change it. The reason for that is if you type 1/7 into your calculator, 1/7 as a fraction is 0.142857 repeated. That's what 1/7 is as a decimal. And it's just pure coincidence that that's identical to what you get for your reference angle. So if I do 1/7 and I round to 3 decimal places, I will get 0.143. And if I do sine inverse of 1/7, and a common mistake that happens with students sometimes on an exam is they just do, instead of finding the reference angle and going sine inverse, they just take that fraction and divide it. And in this case, if someone was marking it, they wouldn't know, did you know what you were doing, or did you just get lucky because our reference angle is the same as the fraction? So you're supposed to inverse it. So then solving between 0 and 2 pi, well, sine is negative, so it'll be quadrant 3 and quadrant 4. So theta will be 3.28 and 6.14. But that's just step 1 of solving our general solution, right? Step 1 of our general solution says solve first between 0 and 2 pi. And then step 2, after you've found those two, then add 2k pi to each of them, where k is an integer, to list every single angle coterminal with those ones. So the beginning part is just solving like you would in grade 11. Of course, now we've added that you have to do it in radians instead of degrees. But the idea is the same. Find your reference angle, use your cast rule to see which quadrant it's in, and then In this case, it's quadrant 3 and 4, so we'll go pi plus our reference angle for quadrant 3, 2 pi minus our reference angle for quadrant 4. Then once you get your answers between 0 and 2 pi, you list them and add 2k pi, because that's like saying those are all the coterminal angles that exist forever. And then you have the general solution, which has every single angle that's possible. So on the top of page 575, we're going to do B. Find the general solution for 5 cos theta plus 1 equals 0. There's the answer only, no work shown, so you can see how you did. Don't write it in example 2. Maybe you still have on 574, maybe you still have some space. Or maybe you still have space there. If not, there is an extra page of blank available on 583. What makes this one the next level? Well, it's quadratic. So normally what do we do with quadratic equations, with trinomials? We factor. But if you try to factor this one, you find that it doesn't factor. So what did you do with quadratic equations that didn't factor in grade 11? You used the quadratic formula. Okay? The quadratic formula is on your formula sheet like this. X equals negative b plus or minus square root of b squared minus 4ac over 2a. And that's for ax squared plus bx plus c equals 0. There's your quadratic formula. I'm going to check if it says the ax squared plus bx plus c, just to confirm that, or not. Yes, it says for ax squared plus bx plus c equals 0. It actually, on your formula sheet, it says this first and this second. There we go. Now it's just like your formula sheet. Now we don't have an x in our equation. We have, and we don't have theta squared. What's being squared here? Tan. So when we go to use this formula, instead of writing x equals, we would write tan theta equals. Our b value is 3, so negative 3 plus or minus the square root of 9 minus 4 times a, which is 1, times c, which is negative 7, all divided by 2a. So we plug in our values from our equation. Our a value is 1 because we have 1 tan squared. Our b value is 3 because we have 3 tan theta. And our c value is negative 7. And simplifying this, we will get tan theta equals negative 3 plus or minus 9 plus 28, all over 2. And we can write 37. We'll do that next.